Welcome to che531. This is numerical methods in chemical engineering. So in this video I'll be talking about how we can solve linear system using MATLAB functions. So primarily we're going to focus on system that can be written in a form of ax equal b, where a is the coefficient matrix, x is the unknown vector, and b is the right-hand side vector. Okay, so an easy example is like you have two unknowns and two equations, x and y, and let's say you have you have a system of equation like, let's say this. Okay, so my a is a 2 by 2, and my x vector is going to be x and y. So if I multiply x or a by x, then in the first equation I get minus 2 times x plus 1 times y. That's equal to b, which is equal to 3. That's the first row. And the second row is going to be minus 4 times x plus y is equal to 5. I have two equations and two unknowns. Let's say we want to solve this using MATLAB. So before actually getting to details of how we can solve it in MATLAB, let's actually make the example even simpler. So for instance, let's look at this equation, 7 times x equals 21. And if you want to solve this, I think an easy approach would be you just divide both sides by 7, and you get x equals 21 by 7, which is 3. Fine. Okay, so this is the first approach. The second approach is, well, what if we multiply both sides by 1 over 7? Right? In that case, x is going to be a reciprocal of 7 times 21, right? And so if you want to do it this way, then you have to calculate 1 over 7 first, which is going to be this number, and then times 21. And if you keep maybe up to 6 digits, 6 decimal digits, then this times 21 is going to be 2.9997. Okay, so we are making a little bit of error here because 1 over 7 is this number and we only record 6 decimal digits. So you see the difference between this approach and this approach. In the first approach, we only did one arithmetic operation, which is division, just divide 21 by 7. In the second approach, this one, equation 4, we did two operations. One is find 1 over 7, so that's one operation. And second is multiply this by 21. So we did two operations to get the result. So comparing the second approach to the first, the second one actually is approximate, it's not accurate. On top of it, we did two operations. Okay, now which one is more preferred, the first approach or the second? Well, we have to see this in MATLAB and see, what MATLAB does and which one actually is implemented in MATLAB. So MATLAB actually does the second approach. It doesn't do the first approach because, this is how we do in our brain, right? But in MATLAB, what it's happening is actually the second approach. So it finds the reciprocal of 7 and then multiply by 21. Okay. So get back to the equations we want to solve. In a generic form, we have ax equal b. You want to solve for x. Maybe from high school you remember to solve this is we multiply both sides by inverse of a, right? And then if you do that, then x is going to be inverse of a times b. So that is not preferred because that's something similar to equation 4. So we have to find the inverse of the coefficient and multiply by the right-hand side. That's pretty much what we learned maybe from high school, that we get the inverse of a, which is similar to inverse of 7, and then times b, now in this case is 21. Why this is bad? Because first of all, you see in approximation, second, you have to do two operations. Okay, so we did more work and as a result, less accurate result. Now imagine your A is much bigger than just one coefficient. What if A is 100 by 100? Then calculating the inverse of that takes a really long time. On top of it, the error you're making is a bit, well, actually it's much more, because now you have 100 numbers or 100 unknowns to solve for. In each of them, if you make a little bit of error overall, the total error actually goes up. So the best way to do it in MATLAB is using backslash operator. And this backslash operator is pretty much like this. Okay, so we don't get to the details of it, but it is faster and it's more accurate. Okay, so now let's focus our attention in how we can do it in MATLAB. So here is the MATLAB window, and if you haven't used MATLAB before, in this class we're going to use MATLAB a lot. So MATLAB has 4 windows. The first one is the upper right corner. This shows the variables that I'm using. Let's say I'm using this script, and whatever variables are here will be shown in this window in the upper left corner. So the values in the first column, the variables in the first column and the corresponding values in the second column. Lower left corner here shows the current directory, the directory that you are in. This is the script window or editor window where you can type and basically see what we implement. And on the lower right corner, this window is going to be the command window, or the window that you see the results. So once you execute your code, you see the result down here. Okay, how we can run the code? Well, in the top ribbon here, you have a green arrow, and that is for running the code. If you click on that, it's going to run the code. Okay, so let's get to some of the details of MATLAB script. Okay, I want to write the equation ax equals b and solve for x. Okay, so the first thing I'm going to do in MATLAB is I'm going to clear my screen. That means every time I'm running the code, I don't want to see anything here. I want to just clear this up. I want to clear this command window. And the command for that is CLC, which means clear screen. All right, second, I'm going to introduce my matrix A. And the way to do that is you can write A equals bracket. So bracket in square bracket in MATLAB means matrix. First row, you just write the numbers with a space between them. As long as you put space between numbers in MATLAB, that is interpreted as one row. So numbers in a row are split by this space. And the space doesn't matter if you put 1 or 5, it still is, one row, 2 columns. If you want to write the second column, you go to the next row and then write the next row with the space between every element of successive columns. Okay, so here's my second row. There's another way to write this, and you can actually write it this way. So you can say A is equal to, and then minus 2, comma 1. So comma means next column. You want to go to next row, you put semicolon, and then minus 4, comma 1, and then close the bracket. So this is identical to this. Right, so this is the second way of writing a matrix. All right, so here's my B vector. It's a column vector. Now I know that when I use semicolon means next row. So 3 is the first row, 5 is the second row. Okay, now I'm going to solve it. And the way to solve it is we use backslash operator, which is this. I'm going to run the code and we see the result. So I'm running the code. And it says x equals minus 1 and 1, which is true. If you plug in minus 1 and 1 into these two equations, you should see that you get the right-hand side. Okay. So what's the benefit of using backslash operator? Well, the benefit is, what if instead of having, so this is 2 by 2. I know that there's a solution to a 2 by 2 system, but what if I have like 3 equations and 2 unknowns, like this? I'm going to comment this out, and to comment out, the shortcut in Mac is Command/ for commenting and Command T for uncommenting. In Windows, I think it's Control R and Control T. Okay, Control R I think for commenting and Control T for uncommenting. So that's the shortcut. Okay. So here's my A, here's my B. Now I know that I have 3 equations and 2 unknowns. Maybe from high school you remember that for 3 equations, 2 unknown you cannot solve. There's no unique solution. And in fact, there's no solution because you have more equations than unknowns. Now in this case, if you want to really solve using the inverse approach that we learned from high school, you see that it's not going to work because A is not square. So let me execute this for you, and you see that I get an error just at this line. Okay, so here it is. It says matrix must be square, and there's an error on line 15, which is exactly this line. So inverse of A times B, which is what we learned from high school, is not a good option. Couple of reasons. One is sometimes A doesn't exist, like this equation where we have more equations than unknown. And second, inverse of A takes time if A is big. Okay, and as a result, it's going to give you more errors in the solution. Okay, so now get back to these 3 equations, 2 unknowns, and we know that there's no unique solution. But if I use my back// operator, then you get an approximate solution, and that is 0.5 and 0.5 and 0.04. So what is the meaning of this solution? I know that there is no solution, so this means you have 3 lines, right? If you have 3 equations, 2 unknowns, means you have 3 lines, and you're trying to find the intersection of the 3, but there is no common intersection, okay? And as a result, there should not be a solution. But this point is an approximate solution, and it's the best, or it gives you the least error out of the 3. In other words, if you plug in this x and y, so the first one is x, the second one is y. If you plug this x and y into this equation, for the first equation you get an error, for the second equation you also get an error, and for the third equation you get another error. You add them up, the sum of total, or the total sum of the errors, okay, will be minimized if you use this x and y. If you use any other x and y than this, the error you're making is bigger than what you do with this approximate solution. By error, I mean you can actually define the error like this. So we can easily say, hey, error is ax minus b. So let's run this and then see what the error is going to be. So I'm going to type my error down here. So okay, here's the x. If you plug x into the original equation, ax minus b, well, I'm just actually moving b to the left side of my equation. So now I'm looking at ax minus b instead of ax equal b. Okay. If x is exact, then ax minus b should have been 0. Now x is approximate, so ax minus b is not 0, and you see that for every equation you get an error. Now with this approximate solution, this error is minimized in a sense that if you square this one and the second one and third one, if you square them and then add them up, the total error will be minimum. Okay, so we can test this by, let's calculate, I'm going to get the sum of square of the error, so let's call that the function to do that is norm. So I'm going to call norm of error, which means the first element squared plus the second one is squared plus the third one is squared, and you get the square root of the sum. That gives you the norm. And if you do that, the norm is 3. So if I use any other x than this, let's say I'm going to guess my x to be 1 and 2. Okay? So I'm going to test this, and you see that the error is going to be more than 3.1. So I'm going to comment this line, rerun the code. You see the error is 16. So with this guess value, the error is much bigger than the approximate error, or the approximate solution. Okay, so now we know what back// operator does. It actually finds the approximate solution with least error. All right, so stay tuned for the next part of solving linear system using MATLAB. Thank you so much for watching.